Good afternoon, everyone, and welcome to this new edition of Up Close, Stories, Objects, and Ideas from Beyond the Galleries. This is the Royal Alberta Museum Virtual Talk Series. My name is Eleonora Sermoneta. I'm the Adult Learning Programmer here at Royal Alberta Museum, and I will be your host during this talk. And before we dive into our talk, I'd like to respectfully acknowledge that the land upon which we stand is Treaty 6 territory, the traditional territory of the Cree and Nakota peoples, and a homeland to the Métis. The space continues to be a gathering space for generations of Dene, Blackfoot, Tsuut'ina, Saulteaux, and Inuit peoples. We honor the cultures, languages, and histories of the indigenous peoples of this land. During this talk session, we will have a presentation by Dr. Corey Scobie, who is one of our museum experts, and this presentation will be followed by a live Q&A, question and answer session. So if you have any questions, please type them in the chat or use the Q&A feature. I will be monitoring the chat and the Q&A, so we're making sure that we don't miss any of your questions. And today's talk is called Attracting Owls, Nest Box Vacancies and Owl Puke. Now that's what I call an intriguing title. Our speaker, Dr. Corey Scobie, is going to tell us all about boreal owls. And these owls live in the boreal forest in North America and the northern Eurasia. So while they're very well studied in Europe, we know little about boreal owls' prey and reproductive success in Alberta. And in order to learn more about them, Corey installed 31 nest boxes to attract pairs of boreal owl to nest. And well, Corey discovered some exciting things. So without further ado, please allow me to introduce our museum expert, Dr. Corey Scobie, Assistant Curator of Ornithology. Just a quick intro for him. Corey has been an assistant curator of ornithology at the Royal Alberta Museum since 2014. Please correct me if I'm wrong. Corey prepares birds, helps manage the ornithology collections, assists with various research projects. Previously, Corey worked with species at risk in the grassland of Alberta and Saskatchewan, where he focused on the effects of human development on burrowing owls, movement patterns, and reproductive success. So thank you, Corey, and feel free to start your presentation whenever you're ready. I'm going to spotlight you. I think that you're already spotlighted. So yeah, people should be able to see you.
Okay, I'm just gonna get my presentation up here. Thank you everybody for attending today. Yes, I'm gonna talk to you today about owls and owl pellets. This is a collaborative project between myself and Dr. Chris Jazz here at the Royal Alberta Museum. Dr. Jazz is the Curator of Quaternary Paleontology. So everybody is got a good look at these guys. So these are boreal owls. This is going to be the species of owl that I'm going to focus on today. So this is an adult boreal owl, not a very big owl, about the same size as a burrowing owl. And if you look in comparison to the great horned owls behind me, quite a bit smaller. And the other specimen I have here, full taxidermy mount of another boreal owl, looks very different than the adult. The young, this is what they look like when they first leave the nest, and then they will molt into their adult plumage before the winter. But I think that they look adorable when they're this small. It almost looks like they're wearing a little fur coat, but cute little charismatic owls. So I'm going to give a bit of background about my experience with owls to begin with. I've worked with owls in a variety of capacities for the last 20 years. I did my graduate work, my PhD. I looked at the influence of human development on burring owl space use, where they were spending their time, and their reproductive success, the number of juveniles they fledged, and if the nest was successful or not. So it was a really big project. We had a lot of field assistance. We collected a lot of data. And one of the pieces of data that we did collect is we had video cameras set up at the nest, and we were recording prey deliveries, prey that was brought back to the nest by the adults to feed the young. But we caught something really interesting when we were looking through the footage. We discovered this neat little clip. So everybody here saw that in the title was named, there was mention of puke. The puke is pellets. So this video was about a burrowing owl coughing up an owl pellet. So this is an adult male, and he's eaten some small mammals or some insects. The undigested parts he's going to cough up. There we go. So that's actually quite a large pellet for that size of owl. It's almost the equivalent of 1.5 pellets for this species. But there you go. That's what it looks like when they eject a pellet. So what exactly is an owl pellet? Well, an owl pellet is the undigested material that they have to get rid of. So when owls go out and they find prey, they eat them, they swallow them, and they're able to digest the soft tissue in their stomach, but the acids aren't strong enough to digest the bones and the feathers and the fur. So in order to pass those, they cough them back up and spit them out as a pellet. So the picture on the left-hand side is me pointing at some burrowing owl pellets. Those are normal size burrowing owl pellets. And on the right-hand side are some snowy owl pellets that have been taken apart. And you can see the variety of species of small mammals and the different shapes of the skulls that were found in those pellets. And obviously the size of the owl, so a big owl like a great horned owl can consume larger prey, and they also have larger pellets. They can be quite large, whereas burrowing owls and boreal owls and even the little pygmy owl, their pellets are going to be even smaller, but also the prey that they consume is going to be smaller overall. So for the burrowing owl project, we collected a lot of pellets. That wasn't the main objective of my part of the project, but we wanted to monitor these nests through time. So every week to 10 days, we visited these nests, really just to confirm that the nest was still active. We collected data, tried to look at the nest to see if we could get the number of eggs, number of young, the age of the young, and various other information that was important for my research. But at the same time, while we're there, we may as well collect the pellets. So you can see in my hand in that top picture is a brown paper bag, and that's what we would store the pellets in. Sometimes they were still wet because they were so fresh, but other times it had rained previously, and so they're still wet and we want them to dry out. So they're stored in paper bags. So for each nest, sometimes we had 5 to 10 bags of pellets for each nest. We monitored about 100 nests every year. And this project, the burrowing owl project, started before my graduate work and ended after I finished. So close to 10 years of nest monitoring and pellets that accumulated over that period of time. So we ended up with quite a collection of burrowing owl pellets. This picture is taken by Tim Showalter. And while I'm talking, you guys can see how many burrowing owl pellets you can count on this mound. So we ended up with so many burrowing owl pellets that in the Canadian Wildlife Service warehouse, we literally had a pallet that a forklift had to lift up and down off the shelf, a pallet full of pellets, all sorted according to the date that they were collected and then sorted by nest. So I'm curious to know how many pellets people saw. I was able to count 11, but actually there might be 12, and maybe you have better eyes than me and you saw more. So what's really interesting, this is a picture of Leanne Heisler. She was a field assistant on the burrowing owl project in 2008, and she helped collect a lot of these pellets, but she also decided to use these pellets for her graduate work. So she was able to extract some really interesting information from these pellets. So if we have a nest location, so we have latitude and longitude, we know where that nest is. And while we look through the pellets, and let's say the species that we find in those pellets, we know that the owl's found within a mile or two of that nest. So we can put a dot on the map and say, this species is found here or in this area. So the map on the right-hand side is from a publication of Leanne Heisler's, and all of the black dots on that map are the burrowing owl nests from which she used pellets for that study. And you're able to answer all sorts of questions with those data that I'll get into a little bit later. I was really interested to find that there is actually a neat connection here from this project back to the Royal Alberta Museum, actually back to the Provincial Museum of Alberta is what it was called at that point in time. Hugh Smith was the curator of vertebrate zoology here at the museum, and then later the curator of mammalogy. And he got a number of pellets. Tim Showalter gave him a number of pellets from burring owls and from great horned owls. And he was able to go through and take the bones out and identify the prey from those pellets. And the list here is the species that he identified that burring owls were eating. So it gives really important information about diet of burring owls. But it also, again, we can put a dot on the map where there's sagebrush voles. We can say that that was collected within a mile or two of each of those nests that they were found in. And then Tim Showalter continued this work later. He took pellets again from great horned owls and some from burring owls and took them apart and looked at the species of small mammals that were contained therein. And once you collect enough of these data, you can start putting dots on a map. Not a lot prior to this work by Smith and Showalter, not a lot was known about the distribution of small mammals in southern Alberta. So the map on the right-hand side, you can see in the southern part of the province, those black dots. And each one of those is a dot of a burring owl or a great horned owl nest where there were sagebrush voles found in the pellets. So those dots, you can start to put them together and you can start to get an idea of what the range would be of this species. And if we look at the publications that contributed to this data, the vast majority of these came from the work that Smith and Showalter did on pellets from owls. So if we take that same map and we can look at the distribution of those dots on the map, here is a scan page out of my Mammals of Alberta book by Patty and Fisher. And in the bottom right-hand corner, you can see a range map. Don't worry, I'm going to blow it up here. And if we look closely, we can see that a lot of those locations from Smith's and Showalter's work contributed to us having a good idea about habitat associations between those species, which then enabled us to come up with a range map. Great information to have. We know that owls are better than humans at sampling small mammals. So the picture on the top right-hand side is the one time that I caught 2 house mice in one snap trap in my compost bin. Aside from that one situation where I was better at sampling small mammals, the owls are much better. So here's a figure out of Heisler and colleagues' paper from 2016, and they showed that the diversity or richness of species found in owl pellets represents distribution of species that humans can find by putting traps out. It's about equivalent or better. Owls are slightly better than humans at sampling the small mammals on the landscape. So identifying small mammals, it's not too difficult differentiating the subfamilies by their outward appearance, what their fur looks like, and other characteristics. So on the left-hand side is a meadow vole. So we have a variety of vole species found within Alberta. They're pretty hard to distinguish from each other, but we can see that a meadow vole has a fairly short tail, a short nose, short ears, which is pretty distinctive of voles in the province. House mouse, long ears, long tail, longer nose, so easy to separate mice species. And then shrews, which is a group of small mammals that most people aren't aware of. Very, very small, really neat little guys. They eat insects exclusively. And actually, one of the smallest mammals in Alberta is a shrew. It's our pygmy shrew. So usually quite easy to differentiate these groups of species by outward appearance. But sometimes we need to identify the species based on their skeletal material. So this is me processing boreal owl pellets, and I was separating the feathers and the fur so that we can look just at that skeletal material, which has the unique characteristics that we need to be able to hopefully identify it to species. So that picture in the top left-hand corner is my finger with a pygmy shrew jawbone. Pretty incredible how small that is, and also shows how delicate and minute these things are. And it is difficult and tedious work to separate this stuff, but it's quite exciting when you can find tiny specimens like that. So even within the pellets, if we have an intact skull, if we have a whole skull, usually pretty easy to identify to subfamily. So the mice, the voles, and the shrews have different shapes to their skulls, which is pretty easy to see. But it's when we're differentiating the different species of vole or the different species of shrew where it becomes a little more difficult, and we need to look at specific characteristics on the teeth. So here's an example where you have to use the teeth to identify it. So sagebrush voles is, I'm going to come back to them a few more times, but in order to identify them, we need to look at the teeth. And when we have pellets, all we have is the skeletal material. So we want to look at the molar that is closest to the front of the mouth, M1. And if we look at that, so it might look like it's more than one tooth, but that's actually one intact molar. And the unique characteristics, the shape of that tooth helps us determine what species it is. But a really neat thing that Dr. Jazz is doing, and he had done with colleagues in this publication I'm going to talk about, that figure on the right-hand side is from that publication. There is quite a bit of variation in that dental morphology, in the shape of that tooth, of that M1. So in that figure, A is actually an extinct morphotype. So it no longer exists. We don't have that shape of tooth in our sagebrush voles anymore. But all the rest, they looked at a huge sample of these teeth from sagebrush voles from southern Saskatchewan, and they were able to identify that there was a lot of variation in that one tooth. And so Dr. Jazz is a paleontologist. And so looking in the fossil record, it's important to describe this type of variation, because if you're looking at something from the fossil record and you're trying to make predictions about extinctions or speciation, you want to know the amount of variation so you're not mistakenly saying something is extinct or not. So very important to record that variation when looking in the fossil record. So heather voles. This figure on the left-hand side is from a different publication that Dr. Jazz and colleagues published a couple of years ago. And they were looking at material from a cave in South Dakota. And they found a number of teeth from lemmings, muskrats, and a few species of voles in this cave. And really interestingly, they found teeth from heather voles here in South Dakota. Now, where this project came from is finding this material. Dr. Jazz realized that there could be quite a bit of variation in the morphology of the teeth from heather voles, especially because it's in the fossil record. It's from quite a ways away. So we should describe that variation in teeth about heather voles. So it's quite interesting. The study area where that heather vole teeth were found in South Dakota is down here. This map shows the current range map of the eastern heather vole in North America. So quite a bit further south in the current range is where they found that heather vole. So, which was deposited when glaciers covered most of Canada, ice sheets covered most of Canada, and the boreal forest was quite a bit further south down into South Dakota. Our study area is up over here. So we'll likely, we want to get as many heather vole teeth as we can so Dr. Jazz can describe that variation. So we're probably going to get mostly eastern heather vole teeth from that area just based on the current range. But there is a chance that we could encounter the western heather vole in that area too. If you look at the range map on the right-hand side, there is the potential that we could encounter them, or even hybrids. And that's some really interesting information that you can get when you examine the skeletal material from pellets. We can start looking at the ranges and distributions of some of these small mammal species. Here's a neat poster from Kate Dollamore, and I'm going to use this to show why we decided on boreal owls as our species that we were going to study for this project. So we wanted an owl that nests in the boreal forest. Well, these guys don't nest in the boreal forest. The burring owl and short-eared owl nest in the grasslands. Short-eared owl also nests in the tundra. The long-eared owl, mostly in aspen parkland, and the northern pygmy owl is a montane species. The snowy owl nests way far north in the tundra. We also wanted a species that nested in cavities because we wanted, it is really hard to find owl nests in the boreal forest. So we wanted to attract them to nest boxes to make it a little bit easier to monitor them, but also helps us collect the pellets. I'll talk a little bit more about that later. So these three species, great horned owl, northern hawk owl, and great gray owl, don't nest in cavities. The other criteria is we needed something that actually foraged, hunted in the coniferous forest, because that's where the heather voles are found. The saw-whet owl, even though it might nest close to or into the boreal forest, it hunts mostly in open areas. The barred owl doesn't eat a lot of heather voles, so that's why we didn't focus on it. So that's why we decided to focus on the boreal owl. So here is a fantastic picture of this cute little guy. This is exactly what you would see if you went out and tried really hard to find a boreal owl during the day. Most likely you're going to find it perched on a branch like this, close to the trunk of the tree. There aren't many of them out there, but if you keep your eyes peeled, that's where you're probably going to see them. Boreal owls are found circumpolar. They're found all across North America, into Eurasia, Europe, Asia, and in Canada, they're found almost everywhere where there are trees. So because they do have a distribution that extends into Europe, they have been studied quite well there. So this red circle shows our study area for context. So I'm going to focus your attention on this column over here that I've circled in red. So this table is taken from a publication that was looking at the use of nest boxes to study boreal owls. And even just looking at this, just within the context of nest boxes, that there are a lot of studies that have looked at these owls in Europe. And actually in Europe and Asia, they're not called boreal owls. They're called Tangmalm's owls, which is named after an individual. So it's a name. So quite different from us calling them boreal owls. But even the studies that were done in the United States and in Alaska, the boreal owls have a very different small mammal community available to them. So they're capturing different prey. Not a lot of work has been done here in Alberta on what boreal owls are eating. So we know from this one publication out of Idaho, which is probably the closest that would come to the small mammal community that's here in Alberta, that they eat a lot of redback voles. About 50% of the biomass or of the prey that they consume is southern redback voles. They eat a lot of deer mice and a lot of other species of voles, and of course, heather voles. They don't eat a ton of heather voles. It's only 5 to 10% of their diet. But it's enough that I think we'll get enough skeletal material for Dr. Jazz to do the work that he needs to with those teeth. Boreal owl habitat. So on the left-hand side is a picture of us installing some nest boxes in what we think is nesting habitat. Boreal owls are a secondary cavity nester. So they rely on other species to excavate their cavity that they then will nest in. So we have two larger species of woodpeckers, the pileated woodpecker and the northern flicker. They predominantly make their nests in poplar trees, trembling aspen or balsam poplar. And so this is where boreal owls are going to be looking for their nests. So we decided to install all of the nest boxes on trembling aspen or balsam poplar trees. On the right-hand side is a picture of more coniferous forest. And this is where boreal owls are hunting, but this is also where the heather voles are likely going to be found. So boreal owls haven't been studied a ton in Alberta, especially their diet, but in the recent past, there's been a couple of studies that have been done on boreal owls in Alberta, and I'm going to talk about them here. So the first one by Domahidi, he looked at distribution of burring owls and boreal owls and started to look for patterns in their associations with habitat and landscapes. So the map on the left-hand side is a predictive model of finding boreal owls during the breeding season. So the dark green areas have the highest probability of finding a boreal owl during the breeding season, and then into the dark red colors where you'd have the lowest probability of finding boreal owls during the breeding season. And if we look at our study area, there is some red patches in there, but there's quite a bit of green and some yellow. So I think we're going to have a good chance of getting some owls to occupy the nest boxes that we installed. This other figure, he was looking at the landscape features around nest boxes that were occupied versus those that were unoccupied. So here he calls empty and owl. And so we can look for, and this is within 100 meters of the nest box. So what kind of vegetation is within that 100 meters and comparing between occupied and unoccupied. So quite a bit less mixed wood forest right around the nest boxes that were occupied versus the nest boxes that were put up. And the other interesting thing is that there's a large amount of forested area around the nest boxes within 100 meters, either coniferous or deciduous. Not a lot of open areas disturbed like roads or well sites or grassland or shrubland. So they need those trees right around their nest box. This is the part of another study that was done by Julia Schoenfeld. So on these figures, they talk about 3 species of owls: barred, great horned owl, and boreal owl. We're focusing on boreal owl. So if you just pay attention to the orange lines, I'll go through these. So looking at probability of occupancy, and we can see on the x-axis here as the proportion of coniferous forest around an area, as it increases, the probability of occupancy increases. So important to know, all of this information helps inform where we're putting up our nest boxes, because we want to ensure the greatest probability of occupancy of our nest boxes. There was not a strong relationship either way with proportion disturbed. So again, the roads and the well sites around a location does not have a huge influence on occupancy by boreal owls, nor does the age of the forest. And when we're looking at detection probability, this is an interesting trend, but as date increases, the probability of detecting a boreal owl increases. And if we look at when that orange line starts to come up, that's right at the beginning of the breeding season. So they obviously use a lot of vocalization during the breeding season, and it continues throughout the breeding season, which again is useful for us when we're trying to detect boreal owls on the landscape. So nest boxes, why use nest boxes? Well, we know that boreal owls will use nest boxes. They're relatively easy and a low effort for studying a species like this. There are plans readily available online. And we know that boreal owls will use nest boxes because they've been used for many, many years in Europe to study. So again, I'm just going to focus your attention on a couple of columns here. And in these columns is the nest box occupancy. So the percent of the nest boxes that they put out, the percent used. So there's quite a bit of variability in these numbers, going all the way from 1% up to 30. But if you look at the top 2 numbers in that column, those are for the areas that are closest to where we are. That's only 1% and 2% occupancy of nest boxes, which is very low. So we're hoping to put out 40 or 50 nest boxes, monitor them for a few years, and see if we can get 1 or 2 nests in there. If we're successful, then we'll likely deploy more nest boxes. Here's a map that shows the distribution of nest boxes that we've installed to date. So this area is northwest of Drayton Valley. And we've put up 32 nest boxes. Again, using a lot of the literature, the information that we got from there. There's some that aren't applicable. There's studies that were done in the mountains of Spain, very different environment than here. So take all of those things with a grain of salt, but tried to put the nest boxes up in locations where we have the highest probability of occupancy. We also, I requested data from Fish and Wildlife Management Information System, the provincial database that keeps record of any wildlife data. And so we requested any data they had on boreal owl detections in this area. And then we were able to put the nest boxes up close to where boreal owls were heard. We don't know if necessarily where those detections are, if they were breeding, but at least we know the owls are spending time there. And if they do like the nest boxes, they have a higher chance of finding them and potentially moving in. So installing nest boxes, much more difficult to do when there's snow on the ground or it's cold outside. This is, again, a picture of us installing nest boxes. These were one of the first 6 nest boxes that we installed in the study area. Here's a picture from up above looking down, obviously on a different day because there's no snow on the ground. That's Chris Jazz on the ground. And so we installed 2 different types of nest box. On the left-hand side, you can see it's a different shape. We had 25 nest boxes that were donated by Joe Baudou. And so we installed those. And then on the right-hand side, I made a number of nest boxes out of cedar. They were originally intended we have a project looking at northern flickers in the hybrid zone west of Sundre. And so we installed a number of nest boxes to see if we could encourage northern flickers to nest in them. And unfortunately, they didn't. So we redeployed them into the boreal owl study area. So to date, we've installed 32 nest boxes. We're looking forward to installing another 9 this year. And then that's probably all that we're going to install for now. And then we'll monitor those over the next couple of years to hopefully get some owls to move in. So once you install nest boxes, it's not just as easy as sitting back and waiting for them to get occupied. They have a higher probability of being occupied if they're clean. So we go out in February. And the reason we go out in February is because the owls start looking for a place to nest at the end of February, beginning of March. They'll start laying eggs. So we go out in February. That picture on the bottom is of us snowshoeing to these sites to check these nest boxes. If they are dirty, like this picture of the one on the left-hand side, so a small bird tried to nest in it during the summer. I don't think they were successful, but we need to take that out and we'll put a little bit of fresh wood chips in there just to make it nice when the owls are looking for a place to nest. Checking the nest boxes is not that difficult because we have an incredible piece of equipment. It's a wireless camera that we're able to put on we have a 50-foot pole that extends, and then we have a little screen that connects with the camera so we can look in nest cavities. So I'm going to show a video here. This is of a northern flicker nest, but it'll show the types of things that we can do with that tool, and it'll also show what it looks like. So there we go. So again, this is a northern flicker nest. So there's 8 eggs. So we use this because we want to look in, we want to see, first of all, to confirm that that's the cavity they're nesting in. So once we see eggs, then we can say, yes, that's the nest location. To monitor the nest, to make sure that it's active every time that we visit, maybe age the number of young. So there we go. That's about 40 feet up. So now I'm going to slowly collapse that long fiberglass pole. And as it gets closer, you're going to be able to see, so beside me is Dr. Jocelyn Houdon, the Curator of Ornithology here at the Royal Alberta Museum. And he's looking at the screen, counting the eggs. Sometimes though, especially if it's quite sunny, it's difficult to see the screen. So a really neat feature of this piece of equipment is you can record a video, or you can take a picture. So if you're not able to count the eggs, or you want a second look to age that young, we can take a picture, and then later when we get in the office, we can look at the pictures and confirm what we thought we saw. So there we go. Jocelyn's holding the tiny little screen. It's not very big, but it does a fantastic job, an invaluable piece of equipment. So monitoring nest boxes. So we go out in February, we need to clean them out, make sure that they're ready for the owls. If they're going to start nesting, we then need to go back to see if anybody has moved in and are nesting. But again, we need to time this based on what the owls are doing. So this figure and the previous one is from a publication that Lisa Priestley did, looking at the phenology, so the timing of boreal owl and saw-whet owl nests. So this figure, the earliest the earliest that young fledged from a boreal owl nest in Alberta was the first week of May. So we know that we need to get out there before that first week of May, just in case we do have an extremely early nest. We don't want to miss it. So actually, we're going to go out here in the next couple of weeks, and we're just going to walk from box to box, put that wireless camera in, see if anybody's moved in. Yeah, but we have to do that before the first week of May. So when we're monitoring nest boxes, we're using that wireless camera on the end of the pole. There's another picture on the left-hand side. Obviously, we're using that not to look in a nest box, but that is a northern flicker nest cavity that we're looking in, a natural cavity. So we go and we peek in. Usually when we're looking in nest boxes, we see just the wood shavings that we left in the nest box. Like the picture on the right-hand side, that's a picture of us, of a nest box that we looked in this February. We were really excited to see this is a picture of a nest box with an owl pellet. And this isn't the first nest box we found with an owl pellet. Last year, we found one that had an owl pellet and the feathers from a dark-eyed junco. So we know that owls, whether they're saw-whet owls or boreal owls, we know that they're finding these nest boxes and they're starting to use them. So it's probably just a matter of time before they decide they're good places to nest. But while we're doing the northern flicker work west of Sundre, we're looking for nest sites. We'll usually find a pair of flickers, and then we got to track down what cavity they're using. And so we end up looking in a variety of cavities. And in 2020, when we peeked the camera inside a cavity, this is what we saw. So quite exciting. I believe it was Jocelyn that found this nest. So a boreal owl nest in a natural cavity. So a really neat picture because there's lots of information that you can get out of that picture. So we have the adult that's right there at the front. But we also, if you look just below, you can see part of an eye, likely of a young that it's brooding, keeping warm. But you can also see a prey item right here. And what's really neat is you can see a little bit of red. So it's very likely a southern redback vole. So lots of information in that little picture, but also a lot of excitement because it was the first boreal owl nest that we had found since we started this project. So once we find a nest, whether it's a northern flicker nest or a boreal owl nest, we put up a trail camera to monitor that nest. We can't go out and visit it every week like we would like to, but if we put up a trail camera, that provides us with a lot of information. If the nest fails, we can go back and we can look at the images or we can look at the video and we can see if a predator went in. We can gain evidence that helps us identify what the cause of the failure of that nest was. But we can also see what stage that nest is at. So these are two really cool pictures of the boreal owl delivering prey to that natural cavity. But most of the pictures are like this. So you see a tail and a bum of an adult going into the cavity, dropping off prey item and then leaving. So a lot of pictures of owl bums on those from that trail camera. So then after the young had fledged from that nest, they had left. We went back. Jocelyn climbed the tree and reached inside and grabbed all of the pellets that were in there. So while the young are in there, they can't cough the pellets out of the cavity. So the bottom of the cavity becomes full of pellets that they then stamp down with their feet. And it actually turns into almost like a brick in the shape of the cavity. So it's called a pellet pad. So it has all the same stuff that individual pellets had. It's just more condensed. So Jocelyn grabbed that material. And then one of my tasks was to separate the skeletal material, the bones, from the feathers, from the fur, and other things that are in there. Because once we've done that, then we can take the skeletal material and we can identify the individual species. And then there's a number of questions that we can answer. So there's some really neat questions that we'd like to answer about boreal owls. First of all, what are they eating here in Alberta? So we'll be able to tell that by identifying the prey in that pellet material. Also, how does the variety and amount of small mammals relate to the landscape around the nest, the vegetation, oil and gas development, any other features? Are there relationships? The figure on the right-hand side is from a publication that Leanne Heisler did with colleagues. And it did a really good job of looking at that relationship between the landscape around the owl nest, where the pellets were collected from, and the species. So this figure looks at the relationship between deer mice and sagebrush voles and amount of cropland. So on the x-axis is percent cropland that was around that owl nest. And then on the y-axis is relative abundance. So we can see as amount of cropland increases, the number of sagebrush voles decreases. And that makes sense. Sagebrush voles rely heavily, they're native grassland specialists. That's what they need. And the number of deer mice are increasing who don't have that strict dependence on native grassland. So we're hoping to be able to answer similar questions with the data that we collect. And some of the questions that I'm most interested in, so where Dr. Jazz comes from, he's really interested in the skeletal material of the heather voles, and I'm really interested in the boreal owls. I'm interested in answering some of these questions specific to boreal owls, like how does their diet influence their reproductive success? If they're eating lots of heather voles, are they more successful? But we can also start to look at questions related to the other landscape features around the nest, like petroleum activities or forestry. So the picture on the right-hand side is a satellite image from our study area, and you can see that there's quite a bit of development. The lighter colored areas are clear cuts from a forestry industry, and you can see the roads with the little squares on the ends of them, and those are well sites. So an area that's heavily developed by oil and gas and forestry. It was really neat when we went out to check the nest boxes this February. There were 2 nest boxes that were right beside an active drilling rig. It was quite loud. And so I'm really curious to see if human-produced sound like that, if that influences the occupancy of those nest boxes. So this is a map showing the landscape around the one nest that we've sampled so far. So that one boreal owl nest that was in the natural cavity, that nest location is the green star that's right in the middle. And that's a 2.8 kilometer radius around. That's kind of the maximum foraging range that an adult boreal owl will use. And so we can start to look at relationship between the small mammals that we've found in those pellets and those landscape features. I want to thank the people that have helped with this project in the field and in the lab. Again, thank you very much to Joe Baudou, who donated those 25 nest boxes to this project. Here's the number of publications that I referenced in this presentation. And I'm happy to answer questions.
Thank you very much, Corey, for your presentation. So we are moving to the next part of our program, which is about questions. And well, brace yourself because we have lots of feedback, lots of interesting questions. So I will start with the Q&A and then I will get other questions that I can see from the chat. So, okay. So Kathleen is saying that in Calgary, they are voting on official bird, and Kathleen is firmly on Team Magpie as they get a bad rep, and would love to learn more about how some owls use abandoned magpie nests.
How owls use abandoned. That's an area topic. A lot of my focus in my research and just interest has been on cavity nesting owls. I know that the species that do use open nests, like great horned owls, that they'll reuse old nests. That if they can, they'll might add a little bit to it. But in fact, there's a number like great gray owls that will just plop right down and start laying eggs. So they like to, it seems like owls generally don't like to make their own nests and rely on others to at least start it for them.
Thank you very much, Corey. And the next question is about, you may cover this. This is what is telling the comment. Did you test the pellets for any sign of pesticides? Is there a means to do that? Did we test what for pesticides? The pellets.
No, actually, I wouldn't. I didn't consider that. That's because the pellets have gone through the digestive tract of an owl. There's it's going to change the chemistry of a lot of the stuff. So pellets might not be the best place to check for pesticides or other toxins. You probably want to go to an active nest. Often, if owls are really good at capturing prey or the prey is really abundant, they'll keep capturing prey and they'll have a prey cache. And so when they get hungry, they can just grab it out of the nest or out of a roost. And so those would probably be the best specimens to sample for any sort of toxins.
Right, on to the next question. Well, it's not really a question, this one. It's more like a feedback. So one of our visitors is saying that the molar, I suppose that the visitors is referring to the molar of a heather vole, appears to be similar to an elephant or a horse.
Oh, wow, that's incredible. I'm going to have to go and find some larger mammal molars and see how similar they are. That's neat.
Next question. So are barred and boreal competitive territorial with one another?
Barred and boreal. I don't believe so. I do know that all of the small species of owls really need to be careful because all of the bigger owls will eat them if they get a chance. And barred owls are quite a bit bigger than boreal owls, so I can see that they would eat them if they got the opportunity. I don't think they compete much for nest sites or prey overall, but just, yeah, I hope that answers your question.
And again, thank you. So I have another question for you. Did you ever find norton flickers using nest boxes in the ones that were aimed at owl? Would love to talk more about urban flickers versus stucco houses versus lack of nests for woodpeckers to nest in.
Okay, I don't know if I caught the main thrust of that question.
I guess it's more about reusing the nest boxes that were supposed to be for owls. So what about our species? Have you ever found any of them in those nest boxes?
Yes, actually, the nest boxes that we had set up for the northern flicker study, we had mountain bluebirds use one nest box. It might have been for multiple years. We definitely had kestrels try and nest in one and then successfully nested in another. So we have had a variety of species nest in them, and that is likely a next stage in this project too. Is I am really curious as to what species of owls are using some of our nest boxes to roost during the winter. So I would like to put up some trail cameras on some of these nest boxes just to see what is going in to use them.
And I actually have another question that I guess you just addressed, because this question was asking, do other species try to use the nest boxes? So I guess that we got this covered.
Yes, and actually that is a big reason that we go out in February to check the nest boxes and to clean them out is because you often get red squirrels or northern flying squirrels that move in and they make a pretty good mess of the nest boxes, and so we need to clean out all the little presents that they leave in there and put some fresh wood chips in there. But yeah, that's the reason we need to go and check them and clean them out.
Yeah, and on this note, how often do you check those boxes?
We try to check them twice. So once in April and once in May, and that should get the early nesters and the late nesters. But that's the reason we're using nest boxes is because it is very low effort. Whereas if we were to go out and try and find a boreal owl nest, we could go out there for weeks and not find a single one. So this is the reason we're using nest boxes for this project.
Okay, wonderful. So the next question is about, well, it's a remark and a question. So this user is saying, so they hunted a junco, yet the pellets only show the rodents?
No, the pellets will show anything that they eat. So I actually haven't taken that one pellet apart just because I'm pretty sure it's going to be the dark-eyed junco that was plucked inside the nest box. But yeah, no, we'll get skeletal material from everything. You could see in that one picture where I was processing the pellets, that I had a tray full of feathers, and those were all washed and then they're dried. And then we try and identify prey from that too. So we try and use all the information, but in the pellets will also be any of the undigestible material that they get from insects as well, the chitin. And so anything that can't be readily digested is coughed back up. So can have anything from insects to birds. They'll eat reptiles, amphibians. So we can find evidence of all their prey species in there, except for the really soft species like worms.
And the next question is, what's the most surprising thing that you found when checking the boxes? Which is something that I wondered myself.
The most interesting thing was probably that the American kestrel nest in the nest box. So when we were relocating the nest boxes out of the northern flicker study area into the Boreal owl study area, we took the nest box down and I opened it up, and it's covered in kind of the fur that you see in pellets. And I was excited because I thought an owl had moved into that nest box, and that nest box was actually pretty close to Yahatinda, which is in the mountains. So it could have been a northern pygmy owl, could have been a saw-whet owl, could have been a boreal owl. But as soon as I started taking that pellet pad apart, and I was finding eggshells, and the eggshells had red coloration on them, and red coloration. And there's only one species that we really know that would have pellets like that and leave a mess like that in a nest box, and it's a kestrel. And it's interesting because a lot of the other raptors, they do have pellets. The hawks, the eagles and the harriers and the falcons, like the kestrel, but they have really strong acid in their stomach, and most of the bone material digests. And so what they cough up is mostly just fur. So that pellet pad ended up being entirely fur, with the smoking gun of the American kestrel eggshells from when the eggs hatched in it. So I was quite disappointed it wasn't an owl, but I was grateful that I saw those eggshell fragments before I got too far in dissecting that pellet pad.
And Corey, one of our visitors is asking if you could please show again the owl that you showed at the beginning of your talk.
Definitely.
Thank you.
This is the little guy, the young one. And here's the adult. So no, they aren't very big at all. And the nest box, the dimensions in the nest box are very specific. And again, it's based on research, but it's so that they can fit in, and not a lot of other things can. So the dimensions and the hole size are all very specific to this species.
And I have another question for you. So this one says, can you set up cameras at the nest height or looking inside the hole itself in a way that doesn't affect the owl behavior?
So when we go and we check a nest box or a nest with the camera, we are probably at the nest site for a few minutes in most cases. So we're in and out. The alternative prior to this, the way to check a nest that's in a cavity was to climb the nest and to look in with a flashlight and a mirror. So that climbing the nest shakes the tree. You're there for longer. Either use a ladder or you use picks on your boots, and those start to damage the tree that the nest is on. So this method, the camera on the end of the pole is really uninvasive. Can you have a remote camera up for the duration of nesting? Yes, not something that is live, because the study area is, that's not something that we are trying to do right now. There's probably the ability to do it if there's cell phone coverage. But when we set up a trail camera, it's just so we look at the data afterwards. It's not live. So if the nest fails, we'll have to go back and look at the images from the trail camera to look at when the nest may have failed. But we don't have cameras that are set up there that record live, just the trail cameras.
Okay, so I have a few more questions for you. This one, it's another interesting one. So if you wanted to observe an owl in their natural environment, what would be the best and least disruptive way to find one?
Actually, it's probably the best way to find an owl is during the winter. If you drive down back roads, you're going to find owls, usually snowy owls. But if you go to areas that are more forested, you can find great gray owls or great horned owls. But if you keep your eyes open during the winter and you do any amount of driving in rural areas, keep your eyes on the fence posts. And you have a good chance of seeing snowy owls. And if you observe them from the road, they should be habituated to the traffic on the road. So if you stay in your car on the road, you have very little impact on their behavior.
And this one is about describing the wash method to safely break down the pellet so it can be examined without degrading the material inside. What could you do?
Sorry, can you say that? What?
If you could describe the wash method to safely break down the pellet so it can be examined without degrading the materials inside.
There's a variety of techniques. One is to just soak the pellets in 10% hydrogen peroxide, and this dissolves all the feathers and the feathers and the fur. So that's all that's left is the skeletal material. So that's kind of the standard. Another way is just to soak it in water and separate it. And that's what I ended up doing with the Boreal owl pellet material that we had collected. And it's just a gentle process. And yeah, because if you try and take them apart while they're dry, some of especially like the tiny, tiny shrew skulls are so fragile that it doesn't take much force to crush it. So we want to keep it as whole as possible. But like I was saying before, the feathers that were in with that pellet material, we did wash it, and I want to identify the bird prey based on the feathers that were in the nest. So if I had soaked them in 10% hydrogen peroxide, we would have lost that information. So my preferred method, just because of what we're looking at specifically, is to soak in water and agitate that way and separate.
Thank you so much, Corey. And I have another visitors who is saying, I would be curious what the impact would be to have 4 nest boxes up and down one tree. If the relationship between different species that use cavities, if that would impact usage. So that's the question. That
would be really neat. So to have multiple nest boxes on a single tree and to see who occupies them. Typically, though, if you do get a nest in an area, the other birds in that community, in that area, know that it's occupied, and a lot of them don't like to share very well. There's obviously species that are quite separate and it's not quite a concern. But if you're introducing nest boxes, then you're looking for secondary cavity nesters to occupy those, and they may not get along very well if you did have well, we know northern flickers didn't use any of our nest boxes, but let's say you had boreal owls and saw-whet owls that are nesting in the same area. I think that they wouldn't get along because they do prey on similar types of small mammals, so they would be competing for resources that way.
All right, and the next one is about threats. So what kind of threats would be likely to cause a nest to fail?
Probably the greatest thing that could happen, one of the adults getting eaten. So other predators in the area, usually owls or raptors, if they ate an adult, then the nest would fail. Otherwise, it would be a predator getting in the nest. I could see a red squirrel getting into a nest that has just eggs, and they would eat the eggs. We've had that happen quite a bit with northern flickers.
Okay. And is the camera that you use made for this specific purpose?
No. Oh, sorry. The camera?
Yes, the camera that you use during your monitoring.
The trail cameras? The trail cameras aren't specific. We bought a couple that are a little more designed a little bit more specifically for taking pictures at closer range. Most trail cameras are designed to take pictures 30 or 40 feet away, whereas we set these up so that they're 10, 15 feet away from the nest. The camera, the wireless camera that we have, yes, is a specialized camera. And we purchased, if you want to send me an email, I can give you the information. The name of the company is actually the 4-letter AOU code for ivory-billed woodpecker. So it's IBWO is the name of the company. And they make these cameras specifically to monitor cavity nesting bird nests.
Okay, we have another couple of questions. So is there a way to know if it's always the same owl or bird that comes back to the same nest box? Unfortunately,
we don't have a way of knowing. We didn't have cameras set up at these, but when we do have cameras, I think it's still, it's going to be difficult. You can look at certain patterns of the feathers that are unique to individuals, but until we start getting these nests that are occupied and capturing the adults and banding them, because then we can use the bands and the specific color combinations of bands to identify individuals. But until we get to that point, no, we won't know if it's the same individuals that are using these nest boxes as roosts during the winter.
All right, and this is how we get to the final question. So can you use autonomous recording devices to monitor owls? Can individuals be identified on the recordings or just to the species level?
Yes, you can use ARUs, autonomous recording units, to monitor owls. Julia Schoenfeld, I talked about some of her work, but a lot of her work was based on detecting owls. Actually, in fact, Zoltan's work as well, using data from ARUs. But the recognizer that Julia developed for boreal owls was not really good at identifying boreal owl calls. And in fact, she had to go through and I think listen to all the recordings herself anyways to identify, because the recognizer was so bad. So yes, they can get picked up. It is time consuming to go through the audio data to identify the boreal owl calls. And I don't know about identifying individual boreal owl calls on a recording, because it would vary quite a bit from their distance from the recorder, as well as what's in between the recorder and the owl. So you probably could, but it would take a lot of work. And I wouldn't be really confident just because there's so many variables that you can't control. You don't know where the owl is.
We actually have one more question. This is good. This is fantastic to have your questions. Thank you very much. So this last one is, does your team accept in pellets that may be found?
Yes, definitely. We're happy to take pellets. We're really only interested in pellets that are found in areas that have a lot of coniferous forest, just because we are interested mostly in heather voles. But if, yeah, we'll definitely take them.
Okay, well, thank you, everyone. These were really good questions, and I feel that we all learn a lot from this experience. So before we say goodbye, I just have a couple of things that I'd like to share. I wanted to let you know that a quick program survey is available at the end of this talk. Obviously, we want to hear from you. We value your input, and we would like to know what kind of programs and experiences you would like to see in the future. So the survey will open automatically in your browser at the end of the talk. And the data will be collected anonymously, of course. So if you want to participate in the survey, you can, and if you don't want to participate in the survey, you can just close your browser. And I also wanted to remind you that we have another talk coming up on April 22nd in the next talk, which is called Collecting a Pandemic, Why, How, and What. We're going to explore what our curatorial team is collecting in order to document the COVID-19 pandemic. The presentation is going to feature several cool objects, so trust me, you don't want to miss this. And make sure to reserve your spot. Well, thank you again for attending Up Close, Stories, Objects, and Ideas from Beyond the Galleries. Thank you very much, Cory, for your compelling presentation. And I hope to see you all at our next talk. Take care, everyone.
Thanks, everyone.